this video we will see how to find derivatives of implicit functions, or what is implicit differentiation. But firstly we have to know what is an implicit function. We are well familiar with such type of function where y is equal to f of x. This function where f of x is equal to some x squared plus 5x. This function written as dependent variable y in terms of independent variable x. Such type of function that we are well familiar with, such type of functions are known as explicit functions. Sometimes the functional relation is not explicit, that it is not in the form of y is equal to f of x, but there is an equation involving x and y. For example, y squared plus xy plus x is equal to 5. This equation is not explicit because it is not written in the form of y is equal to f of x. It's an equation involving both a dependent variable and an independent variable. And we can find the derivative of such type of functions as well. That we are interested in the rate of change of y with respect to x. Now we will see how to find the derivative of implicit function, or how to find or do implicit differentiation. Let's see. Now we will solve this implicit equation or implicit function. First of all, first step is to differentiate with respect this equation with respect to x from both sides. The d by dx of this and d by dx of 5. We will use the summation rule here, that d by dx of y squared plus d by dx of xy plus d by dx of x is equal to, so the rate of change of 5, there is a constant with respect to x, is 0. Now we will use power rule here, that the power comes down to y, decrease in the power to minus 1, that is 1, and then the rate of change of y, d by dx of y, plus we will use product rule here, that the rate of change of the first function, the second function as it is, then the rate of change of the second function, and the first function as it is. So dx by dx is 1 is equal to 0. We will simplify it further because we are interested in finding rate of change of x with respect to y. So 2y dy by dx and x dy by dx, these two terms contain the rate of change of y with respect to x. So 2y plus x, taking out common the rate of change of y with respect to x, and the remaining terms, that is, it is 1, y will go to the next or other side of the equation. This positive y and this positive 1, while going to the other side, becomes negative y negative 1. Then finding the value of dy by dx, 2y plus x will also go to the other side, and so finding the final value dy by dx, thus it will be d by dx of y is equal to minus y minus 1 divided by 2y plus x. So this is the final answer, or the final rate of change of the derivative of this implicit function, and it is really easy to find the derivative or to do implicit differentiation by using the basic theorems of the derivative. Moving to another example, that x square plus 1 by x square and x minus 1 by x square. The situation is that we have to find the derivative of this function with respect to the other function. For example, x square plus 1 by x square is f of x, as it depends on x, and it is g of x. So we're interested in finding the derivative of y with respect to g. Now we'll see how to do such type of differentiation. In order to make it more simpler, let x square plus 1 by x square is equal to y, and x minus 1 by x is equal to some other variable t. So the first step is to find the rate of change of y with respect to x. That is x square plus 1 by x square. We will use summation rule, rate of change of x square plus rate of change of 1 by x square. We will use power rule here. 2x dx by dx is 1, plus we will use quotient rule here, the square of the power, the square of the function in the denominator, that is x to the power 4. Derivative of the function in the numerator, that is 0, the first. So the second function as it is, minus derivative of the second function, that is a function in the denominator, 2x, and the first function that is in the numerator as it is. Solving it, we get minus 2x by x to the power 4, and by further solving it, it will becomes 2x and minus 2 over x cube. This is the rate of change of y with respect to x. Now we will find the rate of change of t with respect to x. D by dx of t is equal to d by dx of x minus 1 by x. So that is dx by dx is equal to 1, minus, using the quotient rule here, square of the function that is in the denominator, then derivative of the first function 0 because 1 is a constant, the second function as it is, minus first function as it is, and the derivative of the second function that is in the denominator, so dx by dx is also 1. So we will get 1 positive, negative, negative become positive, 1 by x square. So this is the rate of change of t with respect to x. But we will have to find the rate of change of this function with respect to this, which means the rate of change of y with respect to t. Now we will use chain rule. We can also write this as x square plus 1 over x square. So this is the rate of change of t with respect to x. Now by using chain rule, what we have to do is just putting the values of dy by dx, that is rate of change of y with respect to x, and dx by dt, rate of change of x with respect to t. Dy by dx, that is 2x minus 2 by x cube, and dx by dt, but we have found the rate of change of t with respect to x, and there is dx by dt. What we have to do is just taking the inverse of dt by dx, that is dx by dt, and putting the value out there. So the value is x square plus 1, and this is the answer. This is what we have to find by finding the dy by dt, the rate of change of y with respect to t, and by using the chain rule we have found it. So in the next video we will figure out the ways of finding the derivative of trigonometric functions. So stay tuned. Goodbye.